As we know, each VLAN is an independent broadcast domain, and the traffic between VLANs is not allowed unless you use some sort of bridging configuration. In this tutorial video, I will show you how you can use a router to bridge traffic between VLANs. This one is going to be the most interesting video yet and will help you significantly with the design and configuration of your small enterprise network. Once again, I will use a scenario with a small company based in 2 different floors in the building. The first device I will use will be the control switch, configured in VTP configuration as shown in the previous videos. I will certainly need to have a access layer switch or floor switch if you wish, and we will have to use a router. Click on the router, make sure that your router will have some fast Ethernet ports configured, so it would be a good idea to put a fast Ethernet module on. Turn back on. Alright, first device to configure will be the control switch. In the control switch, we go to privilege mode, we go to the configuration terminal, and what we want to do in this in the configuration of this switch, we'll have to use the first 20 ports to be used as VTP trunk ports in order to allow trunking between the VTP server and the VTP clients, no matter how many we will have, how many floors or how many departments or how many users we would like to accommodate. And we will leave 4 ports in the end to actually use with trunking with routers of the distribution layer if we wish. So I will select the interface range of fast Ethernet 0, 1 to say 20. I will configure the switch port behavior. And as we want this one to be the server of the VTP server, we would set the behavior to the dynamic desirable. You can see more details in the previous video on VTP trunking. So I exit this, I select a new range, interface range fast Ethernet 021 to 24, and I configure those last 4 ports as trunks. In the trunk, we configure which switch port, which VLANs are allowed. Trunk allowed VLAN all. Actually, if you want to exclude some VLANs from accessing this distribution layer switch, you can make an exemption. Okay, in our scenario, I will allow everybody to get on the distribution layer switch. Okay, and let me exit this configuration. Would be a good idea to configure the VTP, give it a domain name. This is Y2001 Small Enterprise Network, and we can also create some VLANs. Give it a VLAN name, finance VLAN 20, give it a name, for example sales, exit this one and exit again. So now, since we have configured the bottom 4 ports as trunk, we will have to select one of these 4 ports to interconnect with the router, and we will have to use one of the first 20 ports to connect with the switches in the access layer. We're pretty much done with the configuration of the control switch. All we need to do is check the VTP status. Okay, your device is configured as server. That's the domain name. Alright, and let's see what is the VLAN. Okay, we have VLAN 10 and VLAN 20 as active. Good. The next step is actually to configure the router that will be doing the bridging job for us. Let me go to the command line, type no and press return on this first question. We want to configure our devices ourselves. Enable, and now go to the configuration terminal again, give it a host name. You can call it distribution layer router. Actually, it would be a good idea if we give this name here as well. Okay, and now we select the interfaces we would like to actually use to connect to the VTP server. In order to perform the bridging without need to create any sort of routing on the router, the best way is to use sub interfaces. So we use interface fast Ethernet 00, which is the first fast Ethernet interface, physical interface on your router. Only this time we will use the sub interface. This dot 10 actually indicates a sub interface. I'll press enter on this one, and I will have to set the encapsulation to .1Q, and then give the number of the VLAN I would like to associate with this sub interface. I press enter, and I can now configure an IP address to the sub interface: 192.168.1.1.255.255.255.0. Exit that and repeat the procedure for a second sub interface that will be associated with VLAN 20. So interface fast Ethernet, we use exactly the same physical port, only now we have a new sub interface. Select exactly the same encapsulation, .1Q, and then indicate VLAN number. Give an IP address 192.168.say21 to select a different domain, and the subnet mask. Then press enter. On a router, the interfaces are initially down. If you want to start an interface, you need to select it. Okay, and start it. I will not start my interface just yet. I will first connect, and then I'll start my interface. In order to connect a switch to a router, I need a straight through cable. I used fast Ethernet 00 on the router. It's the interface that I've been configuring all this time. Okay, and I'll have to select one of the last 4 ports for the trunk. Now that I've started with the connections, I'm given the opportunity to connect to the switch. Okay, I'll do the fast forward of time, and here, before I do this, let me just check whether the PTP status has been updated. So let me configure. As you can see, the switch is configured as a server. We need to configure it as a client. And exit now. So VTP status. We're a client, and now we have domain name configured. So hopefully the VLANs should be updated now. Good. What we need to do now is associate a number of physical ports with VLAN 1 and another few with VLAN 2. So interface range, fast Ethernet 01 to say 8, switch port access VLAN 10, and then select interface range, fast Ethernet 09 with up to 16, and switch port access VLAN 20, and this show VLAN this time. Okay, VLAN 10 is now associated with those physical ports, and VLAN 20 with these physical ports. Good. We can now come back here, start the interface. As you can see, a green light shows on the router side and an amber light on the switch side. Exit the router configuration, and we can fast forward to see the green light here. Alright, terminals. Let's bring some terminals in. And connect with the switch using the ports that have been used or have been declared as access ports, and of course use appropriate port for the VLAN you would like to associate the terminal with. Fast forward time. Let us configure IP addresses 192.168.1.1. Of course, it's already in use. 1.2, because 1.1 is our gateway. Actually, the fact that it detects that the IP address is in use means that we have we can see now the IP address taken from the router. Use number 3 and 1 down here. Now come here, use 2.2, 2.1 here as the gateway, and 2.3 with 2.1 being the gateway. First thing first, the VLANs work. Okay, you can transfer successfully. Now the question is, can I transfer Inter-VLAN from the finance department to the sales department? No, initially not. The first thing I need to do is select one of these devices and run a ping test. 2.2 for example. Initially, that is a good sign. Actually, the fact that we tried to send some traffic updated routing tables. Normally when you run this ping test, the first couple of attempts will fail because it will give time to the router to update routing tables to allow the bridging to happen. Now if I attempt to send a packet between terminals of different VLANs, it can go, as you can see. Now it will be a good idea to repeat the process for ground floor. That's what I say here. Let me bring some terminals in until the switch loads. Call it ground floor switch. And practically you need to repeat the configuration you did for first floor switch. So enable configuration terminal, host name, ground floor switch, BDP mode client, so that should allow BDP status. Yeah, obviously we need a cable to do that, so let me cable these. Use one of the first ports here and one of the last ports here that we will configure later on. So here we are. We have changed the operation mode and the domain name. We can also try to see VLANs. As you can see, finance and sales are now updated on the switch. What we actually need to do is select interface range fast Ethernet 01 to 20 and configure them as access port. Mode access, okay. Select interface range fast Ethernet 01 to 8 and associate with VLAN 10. And then interface range fast Ethernet 09 to 16 and associate with VLAN 20. Exit and then select interface range fast Ethernet 021 to 24. Okay, and configure as dynamic ports into automatic configuration. And this configuration, so VLAN now, as you can see, port association has been updated, and then so BDP status, okay, information has been updated. Let's then connect. Make sure you select the appropriate ports on your switch. Fast forward time, and let's configure the terminals now. 192.168.1. We have used 2 and 3. Use 4 now. 192.168.1.1. 192.168.1.5. 192.168.1.1. Hopefully that works. Yes. And then 192.168. 2 and 3 are used, so 2, 4. 192.168.2.1. 192.168.2.5. 192.168.2.1. So hopefully that should work again, and that should send data across there and across there. It sometimes fails until it updates all the routing tables on your router here. So if we come to the router and we show IP route, you can see here that these two domains are actually directly connected over the same interface, only two different sub interfaces. This way you can have your access layer connected to a distribution layer or a control switch configured with VTP, so that it can propagate properties of each VLAN to all the switches in the access layer. Okay, and at the same time you can use a router to bridge traffic between VLANs. If you want to block one of the VLANs from communicating with others, you can block it in the trunk. So if we want to configure a third VLAN that shouldn't be able to transfer any sort of traffic to finance or sales department, we can block them on the trunk, on the control switch. Finally, we can use this distribution layer router to configure the DHCP server, as we will see in the following videos. Thanks for watching.